Hi there. Thanks for your question. My name's Kimberly, and I hope I can help you with this. This is a one-dimensional two-body mechanics problem, which might sound complicated, but if we approach it the right way, it's actually quite simple. To start with, I drew a pretty little picture. This has two carts. The cart on the left, which we'll call cart 1, has a mass that I'm labeling as m1 and a velocity, which I'm labeling as v1, and I've drawn it traveling to the right. The cart 2 has mass m2, velocity v2, and I've drawn it traveling to the left. And I've also indicated that things traveling to the right have a positive velocity, things traveling to the left have a negative velocity. So the problem statement also gives us three quantities. Velocity 1 is defined as 0.9 meters per second, mass 1 is 0.46 kilograms, and mass 2 is 0.75 kilograms. I have decided to make v1 positive 0.9 because, like I said, I drew it going to the right. We know that velocity is a vector quantity, meaning it has both a magnitude and a direction. The problem statement only says regarding their directions that they're traveling towards each other, which means that the one on the left is traveling to the right, the one on the right is traveling to the left, and then I picked my own coordinate system so that the going to the right is positive, going to the left is negative. The problem statement also gives us the constraint that the total system momentum is equal to 0. What this means is that the momentum of block 1 plus the momentum of block 2 will equal 0. And the first thing it wants us to know is to determine the velocity on block 2. So to solve this problem, we must first recall the definition of momentum, which is that momentum is another vector quantity related to velocity and mass. It's simply the product of mass and velocity, meaning it's the mass times the velocity in the same direction as velocity. Therefore, we know that the sum of the momentums, which equals 0, as given by the problem statement, and is equal to P1 and P2, which we established, is the same as mass 1 times velocity 1 plus mass 2 times velocity 1. So doing a little algebra, we move m1 v1 over here, and we have to subtract, the minus sign comes over here. Then we divide by m2, so we have all of our knowns on one side and our unknown on the other. And we just plug in the values we had for m1, m2, and v1 on the previous page. 0.46 divided by 0.75 times 0.9 is equal to v2, and we keep this minus sign, so our answer is negative 0.552 meters per second. Equivalently, we could have written v2 is equal to 0.552 meters per second to the left, or it's equal to that speed going in the opposite direction of the vector on v1. Part 2 of the problem asks us to calculate the system's kinetic energy. We can recall the definition of kinetic energy, which is that it's equal to half of the mass times the square of the velocity. This is equivalent to writing it as 1 over 2m times the square of the momentum. But if this form of kinetic energy is confusing to you, feel free to disregard it because it's just as valid as this one, which can be a little simpler and easier to remember. In any case, we know that the total kinetic energy is equal to the kinetic energy of the first block plus the kinetic energy of the second block, which means it's mass 1 v1 squared plus mass 2 v2 squared. We could have also written it with this equation, but I chose to use this one because it's a little easier. And from here, we just plug and chug. 1/2 0.46 times 0.9 squared plus 1/2 0.75 plus times 0.552 squared gives us an answer of 0.300564 joules, which is about 0.3 joules. If you want to check your answer, I would suggest using this formula to see if you get the same answer. If you do 1 over 2 m1 times the momentum plus 1 over 2 m2 times the momentum squared, will that give you 0.3 joules? I hope so. You can also just run the numbers for yourself because I could have made an error with my calculator. Hopefully I didn't. Hope that helps. Let me know if you need any further instruction. Bye-bye.